Good morning. We know from our lessons that electricity is very important form of energy because we use it in operating machines and in lighting. And we know that electricity, we can get it by making electric current. But what are the sources of electric current? We have two sources of electric current. We have electric cell or electrochemical cell and the electric generator or dynamo. What is the difference between both electrochemical cell and the dynamo? So we have electrochemical cells and we have electric generator or dynamo. Electrochemical cells, they are cells which change the chemical energy into electric energy. And so like dry cell and the batteries. And its current, it's called direct current. Direct current. What about the second source, electric generator or dynamo, which change the kinetic energy into electric energy and it's produce alternating electric current. Electric cell like dry cell or electrochemical cell like dry cell and the battery. What about electric generator like the generator found in our car or in the bicycle? So, how many types of electric current we have? We have two types, direct electric current and alternating electric current. The direct electric current, it's produced by electrochemical cells such as dry cell and the battery. What about the alternating? It produced from electric generator or dynamo. The direct, it's unidirectional and it has constant intensity. What about the alternating? Has variable direction and intensity. The direct can't be changed into alternating, but the alternating can be changed into direct. The direct can be transmitted for only short distance. What about the alternating? Can be transmitted for long or short distance. As we said, the direct, its current intensity is constant. What about the alternating? Its current intensity is variable, as we know from this graph. What about the importance of both direct and the direct used in electroplating process? Like when we have any metal, like a spoon made of stainless steel, we can make for it electroplating and we can plate it with silver metal. And it's called electroplating process. So we use here dry cell or battery or the direct current. And also used in operating some electrical appliances. What about the alternating? Used for lighting house and streets and operating also electrical appliances. So if we want to define the direct current, it is the current which has constant intensity and the flow in one direction in the electric circuit. What about the alternating? It is the electric current which has variable intensity and the flow into opposite direction in the electric circuit. Which one we prefer? We sure prefer alternating current is preferred than the direct one because alternating can be transferred for long and can be for long distance and also can be changed into direct current. But how we can connect the cells in the electric circuit? We have two ways of connection for the cell. We have two ways of connection of the cells in the electric circuit. Series connection and parallel connection. The series connection, here we put the cells one after each other, where the negative pole of the first cell will be the pole and the positive pole of the last cell will be the positive pole. So it's called series connection. Here, when we observe, the different poles are connected with each other. So this is called series connection. What about the parallel connection? Here's the parallel connection. We put the batteries here, so all the negative poles connected together. So the similar poles are connected together, and the similar poles here connected together. So in this case, the cell has only one pole, which is the negative pole of all the cells, and the positive pole of all the cells. How can we get the EMF, the electromotive force in case of series connection? For example, if this equal to volt and this 2 volt and this 2 volt, so we make what? 2 plus 2 plus 2. So if I want to get the EMF of the battery, I make what? E1 plus E2 plus E3. If they are similar, they have the same electromotive force, we can make E of the battery EMF equal N times E1. So by this way we can get or we can obtain high EMF. What about in case of parallel connection? This 2 volt, 2 volt, 2 volt. So it has this negative pole and this positive pole. When we get the electromotive force for this battery, so we said there is difference between dry cell and the battery. Battery has many dry cells connected together by any way. So when we get the EMF of the battery equal E1 and it's equal E2 and it's equal also E3. So it's equal E for any cell. So if we want to get low electromotive force, we can connect the dry cells by parallel connection. If we want to draw graph between the relation between the number of cells and the electromotive force for dry cells which are connected in series, by increasing the number, electromotive force will increase, so it's a direct relation. What about in case of parallel? By increasing the number, electromotive force is constant because it's equal E1 for each one. How can we solve the problems about dry cell? If the electromotive force of the battery equals the total EMF for dry cells, so we must connect them in series. If the EMF for the battery equal EMF of one of the cells of the dry cell, we must connect them in parallel. If the EMF of the total equal less than the total and more than one of the dry cell, so some of them connected in series and the others connected in parallel. Let's answer this problem together. A battery consists of 3 cells. The electromotive force for each cell is 3 volt. Calculate the EMF if they are connected in series and if they are connected in parallel. The first case, when they are connected in series. How can we get the EMF? We make what? All the dry cells have the same electromotive force, which is 3 volt. So how can we answer? We use the rule E equal N times E1. So equal what? How many? They are 3 equal 3 times 3 equal 9 volt. What about in case of parallel? Number 2, in case of parallel. So we said that E equal E1 equal 3 volt. Another problem. Calculate the EMF here in these circuits if the EMF for the dry cell equal 1.5. What is the way of connection here? The negative was positive, negative was positive, negative was positive. So here it's series connection. Each one was 1.5. How can we make it? We make 1.5. 3 times 1.5. N times EMF for 1 equal what? Equal 4.5. What about here? I have 2 parallel. So it equal 1.5 and another one series plus 1.5 equal how many? 3 volts. So we can use this way to increase the electromotive force and here to decrease the electromotive force. Another problem. If you have 4 similar cells, the EMF for each one is 1.5 volt. Show by drawing to join them to get EMF for battery equal 3 volt. So in this case, I want to get the total E equal 3. Can I connect them in parallel? No. Can I connect them in series? No. So we must connect some of them in parallel and the other in series. The first way, I can get 3 dry cell and I can connect them in parallel with each other like this shape. So they are connected in parallel and I get another one negative, positive, negative with what? Series. So when I get here 1.5 plus 1.5 equal 3. This is the first one. Can I get 2 parallel with each other and another two parallel with each other. Okay, and I can make like this. And I can make the third way, I can make two series with each other. So this is 3, and I make these two series with two parallel to this dry cell. So it will be like this shape, because this is parallel together and this is parallel together. Yes, it will be like this shape. So I can get 3 volt from these 4 cells. Okay. If we have lemon, ripe lemon, you know that the ripe lemon is act as a battery. We have 4 fresh ripe lemons and 4 copper ribbons and 4 ribbons of lead and the copper wire and 2 lamps. If we connect the 4 lemons time series and the other time parallel connection, and we will observe together the lightning of the lamp, we found in case of series it has more glowing, more lightning, because in EMF in case of series will be more than in case of parallel. We have the last problem in this lesson. In this electric circuit we want to get more glowing for this lamp. How can we make this? I have many dry cells. They connected in series and in parallel connection. I want to get high illumination for the lamp, so I must connect them in series. How can I make this to be in series connection? By opening K2 and K3 and closing of K1 and K4, so they are connected in series, so we can get high electromotive force, and so the illumination of electric lamp will increase.